So what I'm going to be proving here is proof 19.2, which states that given the associative law and the anti-commutative law for wedge products for basis 1 forms, we're going to prove that the basis 1 form commutes with an even L form and anti-commutative is odd, and then we're going to generalize this to the most base to the general case. Okay, cool. So first, we're starting out with the associative law, which states that if we're given forms, we could rearrange the parentheses and it'd be okay. We're also given the anti-commutative law, which states that if we wedge two together, we're going to get the negative of them wedged in the opposite order. Okay, so we're going to first prove this for the base case where L is equal to 2. So we're wedging a 1 form with a 2 form. We could rearrange by the associative law to get this. Take the anti-commutative law and switch the order inside. Associative law again to get this. Anti-commutative law inside the parentheses. And then associative law. So this the wedge product is backwards and the signs are still the same, so we've proved it for the base case where L equals 2. Now we're going to use our inductive hypothesis and hypothesize that if we have a 1 form wedged with an L form where L is even, then the sign won't change. So we could rewrite this as dxj wedge L wedge dxj, so this as I, since an even plus 2 more is still an even. This is equivalent to this whenever we rearrange the parentheses. We switch the order inside, and by the our base case, we know that they're still going to be the same. This is equivalent to this by the associative law and also by our base case. Okay, so these two are wedged together in the opposite order and their signs are still the same. So we've proved that for the base case that if L equals 2 and if L is equal to some I that's even plus 2, it works. Now we're going to prove it for the base case where L is equal to 1 and then prove it for odds in general. So the base case L equals 1, of course, is just this, which we were given. So yay! We're going to use our inductive hypothesis and hypothesize that if L is odd, we're going to get negative. This can be rewritten as dxi wedge rearrange, and based on our base case we could do dxj wedge dxk. So this is by the associative law. By our base case we're going to get this, and this is equal to the negative of an L form wedge dxj wedge dxk wedge dxi. These are wedged together in opposite order and they have a negative in front, so we prove that if L is an odd and we do it for L plus 2, which is also an odd number, then we're going to get a negative. So the general thing is that since we proved it for 1 form, we could insert anything in here, and we know that an even form wedged with any form is going to give us the same sign. if it's an odd form, then we're going to have to do a number of switches. So our conclusion is that if both I and L are odd, then our wedge product is anti-commutative, and if either or are even, then our wedge product is commutative. And that finishes proof 19.2. Yay!